Winter 1960, Mackenzie Basin, northern Canada. 5 Caterpillar D8s move out onto a frozen river to build a road that exists only in cold weather. Then the ice begins to answer back. What looked solid from the bank was not solid everywhere. To understand why 5 Caterpillar D8s were out on river ice in the winter of 1960, you have to start with the road that did not exist for most of the year. Northern Canada was still moving by water, by air, or not at all. In the Mackenzie Basin, distance was not measured only in miles. It was measured in seasons. Barges could move freight when the river was open. Aircraft could move men, mail, and high-value cargo when weather allowed. But heavy loads were another matter. Fuel drums, bridge timbers, machinery parts, camp supplies, generators, compressors, and tracked equipment needed a route with carrying capacity, not just access. In summer, the river was an obstacle and a corridor at the same time. In winter, if the cold held long enough, it became a road. That was the logic behind the Mackenzie Winter Road Push of 1960. Crews were trying to force a temporary freight line across frozen ground, muskeg, cutbanks, and river crossings before the season began to turn. The road was not a polished engineered highway. It was a narrow, hard-won corridor built under Arctic time pressure. Every mile depended on temperature. Every crossing depended on ice. And every delay threatened the entire haul season behind it. Back to the machine. The Caterpillar D8 was the kind of tractor chosen when lighter equipment was no longer enough. By 1960, several D8 variants were working across northern jobs because they offered the one thing the winter road builders needed most: mass combined with sustained push power. Depending on configuration, a D8 of that era weighed well over 30 tons before additional fuel, operator gear, or attachments were counted. It had the blade capacity to cut approaches, shove wind-blown snow clear, level frozen ridges, and drag material across rough sections where trucks could not yet go. It was built for traction, not delicacy. That mattered because river ice does not fail like a road surface. It behaves more like a loaded structural plate spread over moving water. On paper, thicker ice means greater capacity. In the field, it is never that simple. Ice thickness varies across channels. Snow cover insulates and slows growth. Current eats from below. Pressure ridges create hard zones beside weak ones. Overflow water can refreeze into deceptive layers that look solid from above but do not carry load the same way as clear black ice formed in sustained cold. A crossing can appear uniform. It is not. The crews pushing the Mackenzie line knew that. They were not amateurs wandering onto a frozen river. They had already spent weeks reading terrain the way northern operators had to read it. By sound, by color, by drill holes, by the way tracked machines settled, by the way exhaust hung in the cold, by the way the river announced weak places long before it opened them. But knowledge did not remove risk. It only narrowed the margin. By the time the 5 D8s approached the critical river section, the operation was already under pressure. Freight movement farther south depended on the route being opened quickly enough to support later convoys. Temporary winter roads had a short life. Build too early, and the ground beneath the snow was not yet locked hard enough. Build too late, and spring breakup would erase the work before the season paid for itself. The numbers looked manageable. The reality was not. Reports from northern road operations in that era show the same pattern again and again. Lead crews would move ahead with tracked tractors, cutting and packing the route, probing ice, improving approaches, and identifying whether loaded trucks could follow. Where channels widened, the problem changed. Wide water often meant slower freeze consistency, especially where current separated into multiple runs beneath the surface. What looked like one frozen crossing from the bank could conceal several different ice conditions within a few hundred yards. Mechanically, the problem was simple. A heavy crawler does not apply its weight to ice the way a truck does through tires. But it does something else that can be just as dangerous. Its tracks spread the load, yet the machine's total mass still pushes a bending wave ahead of it. If speed, spacing, and ice quality are wrong, That wave can amplify stress instead of merely passing through. The machine keeps moving. The ice beneath it begins to flex. Once flex becomes fracture, horsepower stops mattering. The D8s were there because smaller tractors could not guarantee the route. The approaches had to be cut. Snow had to be stripped from sections where bare ice growth was needed. Ramps had to be shaped down to the river. In some places, the tractors were effectively building the crossing while also being asked to prove it. That is the contradiction at the center of almost every winter road story. The machines needed the road, but the road often needed the machines first. Conditions along the Mackenzie that winter were severe even by regional standards. Temperatures could hold low enough to preserve the surface, then shift just enough with wind, snowdrift, and current to create local weakness no crew could fully standardize. One stretch would ring hard under steel, the next would answer with a duller note. That matters because experienced operators listened for changes. Sharp, dry track noise over good ice was one thing. A lower, softer response under load was another. In that country, sound was warning. The 5 D8s did not enter the operation as a dramatic final gamble. They entered as working machines on a job that still appeared possible. That is usually how these events begin. Not with panic, with routine under pressure. A measured push. A known machine. A river that looked ready. It was ready in some places. Not in all of them. And when the tractors moved farther out onto the crossing, the difference between those two facts began to matter. The first sign was not dramatic. It rarely is. One of the lead tractors began to feel wrong under the operator before anything visibly failed. The track noise changed. The machine still had forward bite, still had engine power, but the surface response had softened. Under those conditions, that change mattered more than the exhaust note or the blade load. Good river ice answers a crawler with a hard, dry report. Weakening ice gives back something lower, duller, and alive. The machine was still moving. The river beneath it was beginning to move with it. Then the surface started to sag, not collapse all at once, sag. A shallow flex first, visible ahead of the tracks and then alongside them, the ice plate bending under a load it could no longer distribute cleanly. That was the moment the crossing stopped being routine. Once a heavy tractor induces visible deflection in river ice, the problem is no longer traction. It is structural failure already in progress. The operator had only seconds to decide whether to keep momentum or stop and try to reverse. On paper, backing out sounds safer. In the field, it can be worse. A crawler that stops on weakening ice concentrates load on a plate that is already flexing. The bending wave loses its forward movement. The machine settles. If the ice is already cracked beneath the snow cover, reversing can simply break open what was still barely holding. The recovery plan assumed there would be time for judgment. The site delivered almost none. The lead D8 dropped first. The fracture opened along one side of the track line and then ran forward in a dark split beneath the snow crust. Water surged up through the break, black against the pale surface. The front of the tractor pitched down as the ice edge failed under the engine mass. A machine of that size does not disappear instantly. It goes in by stages, nose down first, blade low, track frames hanging for a moment as the rear section still finds partial support. Then the support vanishes too. Behind it, the following tractors were now trapped by the worst geometry possible. Heavy machines on the same crossing, limited room to maneuver, and a failure mechanism spreading through a live ice sheet. Spacing matters on ice, so does timing. If multiple machines are too close, one failure can load the surrounding plate and weaken it for the next. What failed next was predictable. A second D8 tried to hold position and broke through under its own weight as the ice around the first collapse line destabilized. The rear of the machine settled hard, then dropped deeper as the broken slab rotated under the tracks. Another operator cut power and tried to climb back toward firmer ice, but the surface had already turned from roadway to debris field. Fractured plates, rising water, slush, and unsupported edges hidden under snow. The machine had enough power, it did not have enough support. By the time the third tractor went in, the crossing had become a chain reaction. Not every machine vanished completely. Some hung at angles, partly supported by broken ice shelves and the buoyancy resistance of water and slush. Others settled deeper, cab level or near it, with only upper structure and exhaust visible above the opening. But for the crews on the river, the distinction mattered less than the fact itself. The crossing had failed under 5 working tractors. The route was gone, back to the machine. A Caterpillar D8 was built to push earth, drag loads, cut approaches, and survive punishing ground contact. It was not built for immersion in moving winter water. Once the lower hull, final drives, and engine compartments are exposed to freezing river water and slush, the machine enters a different kind of crisis. Water floods track frames and undercarriage cavities. Ice forms around rollers and idlers. If the engine stalls during partial submersion, intake and exhaust risk taking in water depending on angle and depth. Lubricants can be contaminated. Control linkages freeze. Electrical systems, already limited by cold, become secondary to the basic question of whether the tractor can even be rigged before it settles farther. And that was the next problem. Recovery. In stable ground conditions, a stuck crawler can be pulled if there is anchor capacity, line angle, and enough machine on solid footing to do the work. On broken river ice, none of those conditions can be assumed. The obvious solution would have been another heavy tractor on the line. In the field, it was exactly the wrong answer. Sending more weight onto a fractured crossing risked losing more machines. The first failure was not the engine. It was the surface. Adding load would only repeat the mechanism, so the crews had to work from the margins. That meant probing from safer ice, widening access carefully, and trying to establish whether any of the submerged or half-submerged tractors could be reached with cable from shoreward positions or from reinforced sections of the crossing. Under those conditions, even attaching rigging becomes dangerous work. Men have to approach broken edges that shift underfoot while water wells through cracks, and the cold works against hand strength, judgment, and time. The machines were still there, but they were no longer ordinary equipment. They were loads in unstable water. Some effort was made to save what could be saved quickly. A tractor hanging high enough might be pulled before the broken plate around it deteriorated further. But river ice after a breakthrough does not improve with disturbance. It gets worse. Every pull transfers shock. Every movement breaks more edge. Every hour of exposure changes the geometry as water refreezes in some places and undermines others in others. On paper, this should have worked. In the field, it did not. The crossing was abandoned as a working route. That consequence mattered beyond the 5 tractors themselves. The winter road was a seasonal system. Lose a key crossing and the route behind it stalls. Freight schedules slip, fuel and supply movement have to be rerouted, delayed, or reduced. A temporary northern road does not have much slack built into it. One failed section can consume the season. What happened here outlived the machines because it exposed the hard limit of pushing heavy crawler operations onto a river that had not frozen as uniformly as the plan required. The aftermath was practical before it was historical. Crews salvaged what they could from accessible positions. Some equipment may have been stripped where recovery was impossible or uneconomic. Some machines likely remained trapped until later conditions. Lower water, heavier cold, or specialized planning made partial recovery possible. But the central fact remained unchanged. 5 D8s had gone through the Mackenzie ice during a winter road operation that depended on confidence in the crossing. That confidence did not survive. For operators and engineers, the lesson was not that D8s were too heavy for the north. Heavy crawlers remained essential to northern road building for decades afterward. The lesson was narrower and more important. River ice is not a road simply because it is frozen. It is a temporary structure with variable thickness, hidden current, changing support conditions, and failure behavior that punishes assumptions. The blade could cut the approach. The tracks could carry the load. The river beneath them could still refuse the machine. In later years, northern ice road practice became more disciplined about spacing. speed control, route proofing, drilling, load sequencing, and the difference between surface appearance and structural capacity. Some of that knowledge had always existed in local experience. Incidents like this forced it into harder operational memory. The numbers looked manageable. The reality was not. The site is quiet now, at least compared with the sound of 5 big tractors working winter approaches on a northern river. No exhaust hanging in the cold, no steel track bite, no blade noise carrying across the ice. Just the knowledge that for one stretch of the 1960 season, the Mackenzie stopped being a road and became water again. The machines went onto the river to build access. The river took them instead, and that is why this incident still matters.